Hello, Federico.
Hello, Genevieve.
Let's continue maybe filling the frames of our famous conveyor. Maybe
Sure.
let's bring on the screen here, yes, to remind everyone that we have a ring with a lot of conveyors. And in the last videos, we added the end photocell, just that if it's seeing a box or not.
Yeah.
And yeah, maybe the next step is simply to add a motor and a bit of logic when the photocell sees or not. Maybe we can start the conveyor. Maybe let's go in the code and show us this, Federico.
So in this case, we are focusing on the children frame of each conveyor because the motor itself will be a component. So again, a cat, but controlled from a parent, in this case, the conveyor. Let's search for it again in the green library here in the motor folder. We can use a motor VSD because typically we want to change the speed of our logistic line in the real application.
Mm-hmm.
We can drag and drop it here. So the motor VSD is in our conveyor. We can rename it as motor. Okay.
Okay.
And, let's go inside just to check and see again. We have the same frame organization of all the component cat we are going to use in our application. So field input interface, initialization, internal, the logics, and so on. Okay. In this case, we don't need to customize it the same way we did with the digital input, creating my digital input. This motor is already ready to be used.
Okay.
And how we can do it? Okay. The idea is that here in the logics frame, the most important one, we create something locally that can give the proper command to the motor, switch it on, switch it off, give
Okay.
it the speed value, and so on. Okay. See
So
here
maybe
that
to follow this vertical slicing that I was talking in an earlier video, we should create maybe a very simple basic block to just give command, making sure that everything is connected, and maybe also update the UI to make sure that the motor is in a good state.
yes, that's what we're going to do. So as you said, the right object to use now is the basic function block. So create a new item. We can call it conveyor logics, for example. Okay.
Okay.
Again, here we have the default events and variables. We can leave for the moment the init and init o. It can be useful in this case. And let's customize a bit the input and output variable of this object without focusing on the internal code. It is not the purpose of our videos in this phase. So first of all, let's check on the motor VSD. Here, you see that in its functional input interface, we have this I control motor VSD from green library. Okay, let's go inside of it to understand a bit how it is made up. So we go in motors, motor VSD. Okay. So you see here that basically we are giving the on-off command and the speed set point.
Okay.
At this stage of our application, we just need these two variables. Okay.
Mm-hmm.
So the idea is that inside our conveyor logic, here in the plug form, we can create an adapter like motor control. Okay. And the type of this adapter, it is directly selected from green library. So let's search for it. I control motor VSD. Okay.
Okay.
Perfect. This means that internally in the code of the basic, we'll be able to assign values, okay, true or false for the on-off, or 50% of the speed for the speed set point, and to update this adapter, okay, that now is available in the output interface of our basic. So let's insert it here. in our conveyor cut. It is the core logics of our component. The modular control is able to be connected
Okay.
to the children. Okay, perfect. Well,
I saw that you left the init pin, meaning that we could maybe at the start to give a default value and to see our block. So probably we'll use the top left frame called init for this.
yeah, internally in the block, we can just use this default state of the state machine, and inside we can we go in the algorithm, okay, and maybe at the initialization phase of the application, the most right thing to do is to set the on-off false, right? And the motor control speed set point. So you see on-off and speed set point are taken directly from green library adapter. Okay. To 0.0.
Okay.
Okay.
Maybe you should also update in the ECC. So in the diagram, there is still the request.
Yeah.
That is not needed anymore. So you can maybe exactly. Okay, very good.
As you said, now this input and output initialization event has to be connected somewhere. Okay.
Yeah.
So the idea is that we complete very fast all these frame, and first of all, we can search for our conveyor IDs. So you remember this is a special block of EIE, and you can use it to communicate directly with HMI symbol. Okay. Always remember to put here the true state. And in the initialization frame, we can use a different thing. And if you are the expert of the initialization, we can use PLC start, event chain.
So it really depends on which block. For now, I will really start with the e-restart if we don't have it in the library, if we don't have a block directly for the library. But if we have, no, wait 1 second. We have the green library, and we know that the green library rely on this app_init functionality. So maybe just do a event chain, an event chain, and then we will refactor later.
Like this.
Exactly.
So this is our init. Okay. So
we know that the name is app_init, and then we should name it directly like this. Okay, we should assign a priority probably.
Just to show a bit.
Yeah.
See that inside
okay. But actually, we saw it. If you go one more up, we can directly use this block.
The init object.
If I don't know what is the name.
Then we have to use also the adapter.
Okay. But then you can then copy this event chain head directly. Like this, you have all the good properties.
Yeah. So let's remove this, paste it.
Okay.
Perfect. And so the init event is started here. We can connect it to init here. I just kept pressed my control button on the keyboard. So I have the link.
Like this, you don't have the line, but you have the two boxes. Very nice trick, Federico.
Yeah. I connect the initio event from the IDs to our core logics. Okay. And then
the last thing is that we need to send an ACK to the block saying that I am fully initialized. You can go to the next level. Okay.
Yeah. So internally, our conveyor is totally initialized. Perfect. So I think that we can customize again a bit this conveyor logic. Okay. suppose we want to create a local logics where the conveyor starts only if it is receiving a box, and then it stops when the box is removed, is downloaded. Okay. Of course, to do such a logic, you need to receive all the photocell signal, okay, from the previous conveyor, and that's how we are going to use this iLoop chain adapter. And you will pass the same information to the next conveyor through this iLoop chain again, okay? And internally, you will be able to stop your local conveyor using your end photocell. So as soon as the box passed through the end photocell, okay, your conveyor will be able to stop. Okay,
yeah.
That's an example. So let's first of all customize a bit the interface of our basic function block. So we will need, we can say, an input, always capital letter, status. Okay. We need also and photocell information. Okay.
Okay.
Perfect. As an input variables, we need the input. We need to know if the input conveyor, the previous one, is unloading a box.
Okay.
And of course, it is a Boolean condition. We can directly connect it to input conveyor status. Perfect. And photocell, so the information of our internal photocell of our conveyor.
Okay.
The event. Okay. Perfect. Let's go back to the cat. So, as I told you, we will receive this event from adapter or from the digital input. For the end photocell, it is here available. Okay. Let's hide it. Okay. And for the input conveyor status, input conveyor unloading, we will use the iLoop chain, of course.
Yeah, to have the status or the information of the previous conveyor. Okay.
Yep. So let's go inside our custom adapter iLoop chain. As an output event, we can call it, for example, status feedback. Okay. And the variable associated are loading, for example, and unloading. Both of them are Boolean connected to status feedback.
Okay.
And let's go inside our conveyor. See here it is the socket form and the same adapter, the plug form here. So the interface seems to be just switched. But in this way, you can receive information from the previous conveyor. It is unloading a box. It is event. Okay. And now our conveyor want to inform the next one.
Yes.
So our internal end photocell will be connected to the unloading state. See, this very smart structure allows you to implement the right communication inside your ring. So
and it's very descriptive the way you do it, because you explain where it's coming, what signal, and we are enhancing what is going through this adapter, these yellow cables. So we add functionality without changing the upper layer, which is also a key point.
Yeah, exactly. And of course, now we have here our motor, we can enhance also our HMI structure. Okay, we can stay inside our conveyor. Okay, you see in the subcat now we have our motor green library available. It is in this case a very simple motor. Okay.
Okay.
Let's keep it inside. And we can do the same also for the S vertical.
Mm-hmm. Okay. And then you can show maybe on the HMI.
Yeah.
So we should deploy the controller probably to see it on the HMI that it's mapped to the right device with the new code.
Yeah. So let's clean it first.
Yeah.
And deploy.
All right. Let's have a look at the HMI now. Okay, the ping disappeared. That means that the code is there and probably up and running. Very good. Thank you, Federico. We saw now how to enhance a bit the adapter and have a bit of logic going on. Thank you.
Thank you, Genevieve.